So in this question, it's getting a little bit interesting because they've just given us a graph of the derivative. It's not the original function, that's the derivative. So let's see what we can piece together for this one. So suppose we have a function and you know that f at 2 is equal to 16. Right away, I'm using my superpowers to know that I'm pretty sure we're going to be linearizing this thing at x equals 2. Just because they give us that point, you know, whenever you get a linearization thing, you have to center it somewhere. You need to know where that's, you know, that's why they're giving us that. Okay, and the graph of its derivative is here. Well, we're going to need this information because we need to know what the slope of our tangent line is when x is equal to 2. And we can use this information to find it. That's what the derivative does. It gives you the slopes of the tangent lines. So for example, if I look here at 1, what's the slope of f, of the tangent line to f, when x is equal to 1? You can go to the graph and say, well, at 1, it's 5. At 2, it's whatever. And then at 3, it's whatever. I just can't say the answer, I don't think. But it's, you know, once you understand what information this graph is giving you, it's not too bad. Okay. So use linear approximation to estimate f of 2.1. So you have to actually come up with your function L of x, which is just the equation of the tangent line to the graph f at the point x equals 2. So you have your slope, we talked about that just now, and then you have your point here. You can use that to compute the actual equation of the line, and then that's your L of x. And into that, you pop in 2.1, and that's your answer for A. Okay. Hopefully that's okay. It gets interesting. Part B, of course, part B, like, yeah, I know you can put just like too big or too small in your web work, and it's really, really easy to guess, to actually get the answer and get the marks for this one. But this one is really, really important. I really want to stress that this is a wonderful question. It's really, really good. And it's important to understand what the answer is and why it's that way. Okay, so I wrote some just some like prompting questions that help me think about it, or like it's what I think about when I'm thinking about this type of problem. So what is happening to the slope as x increases from 1 to 3? Let's go look. As x increases from 1 to 3, the slope is decreasing. It's going down like this. So try and picture a function now in your brain. I'll try and do it this way so you can see a function where x is increasing and the slope is decreasing. It has to go like that. The slopes have to be getting lower and lower and lower. They have to be decreasing. Okay, so the function has to be going like that. Picture if this was my function here, what that would make the function look like in terms of concavity. But I'm getting ahead of myself because I wrote these questions down. Let's just look at them. What impact does that have on the shape of my graph f at x? Well, that's what we just talked about now. If the slopes are decreasing, it goes down like that. Okay, cool. So it has to be going down also. Can I infer information about the concavity of my graph f at x? And yeah, for sure. It has to be concave down if the slopes are decreasing. Okay, interesting. Now, does the slope of my linearization approximation change as x increases from 1 to 3? Good question. What happens to the slope of my linearization as x goes from 1 to 3? Well, remember, a linearization is a line. The slopes of a line don't change. Remember, if you take the derivative of a line, like 2x plus 5, the derivative is 2. The slope is 2 everywhere. For a line, the slope is constant always. So our linearization approximation, whatever it's going to end up being, as x goes from 1 to 3, it just stays exactly on that line. Whereas our original function is decreasing the whole time. So which one's going to be on top of which? That's what I mean by pull it all together. That you should understand. I think that comes up one more time in this, one or two more times in this web work. You need to know how you get that from this. Okay, so think about that a lot. Don't worry if it takes you a long time to think about these things for the first time. Seriously, you can take hours to digest new information like this, especially these tough concepts. These are tough calculus concepts, so you're doing great. So don't get down if it's taking you a little bit of time. So yeah, hopefully that helps. And as always, if you want me to personally help you pass your course, click in the description. Thank you for watching, and until the next video.